Tactile paving. Kicking off at number 10 are the bright yellow tiles built into city sidewalks. They are actually called tactile paving, invented in Japan in 1965 by an engineer named Seiichi Miyake. Miyake spent his own money to create them after his close friend began losing his eyesight. He wanted a universal physical language on the street so his friend could navigate busy traffic areas safely without a guide. The shapes are a highly specific code. Raised circular blister dots warn a person that they are approaching an immediate danger, like a busy traffic intersection or a subway ledge, while long, straight parallel ridges act as a safe go pathway. Cat's eyes. At number 9 are cat's eyes, the small raised reflective studs embedded in the middle of highways. They were invented in 1934 by Percy Shaw in the United Kingdom. Shaw was driving home on a pitch-black, foggy night and almost steered his car straight off a steep cliff. He only survived because his headlights reflected back in the eyes of a stray cat sitting on a fence. He went straight to his workshop to recreate that life-saving reflection on the asphalt. The truly genius part of his design is that they are entirely self-cleaning. Every time a heavy car tire runs over a cat's eye, the rubber reflector is pushed down into a cast iron housing where a built-in rubber wiper scrapes away all the mud and grime. The secret code on glass bottles. Number 8 takes us to the bottom of your favorite glass soda or beer bottle. If you flip one over and look closely at the base, you'll see a bizarre row of tiny raised dots, often accompanied by a single letter like E. This isn't a factory defect. It's an industrial tracking code meant exclusively for automated factory cameras. Glass manufacturing requires extreme heat and pressure, and bottles occasionally fail and explode on assembly lines. Glass manufacturing engineers implemented this system so that if a bottle bursts, high-speed laser scanners instantly read the raised dots on the surrounding shards to pinpoint exactly which mold machine caused the structural error. This allows them to shut down that specific machine instantly without stopping the entire factory line. The slits in fast food drink lids. At number 7 is the plastic lid on your fast food fountain drink. Everyone knows about the little pressed-down bubbles labeled Diet or Cola, but the real engineering masterpiece is the cross-shaped slit right in the center where you push your straw. Fast food design engineers realized that if the lid was completely solid around the straw, drinking from it would create a powerful internal vacuum. The plastic cup would slowly collapse inward, and your soda would violently splash out of the straw every time you took a sip. The 4 tiny slits allow just enough air to flow into the cup while you drink, equalizing the hydraulic pressure so your beverage flows perfectly smoothly. The road zigzags. Coming in at number 6 are the aggressive white zigzag lines painted on the lanes of UK and European roads. Driving lanes are almost always marked by straight, predictable dashed lines. But right before you reach a pedestrian crosswalk, traffic engineers warp the paint into a jagged zigzag. This is a brilliant piece of subconscious psychological design. The zigzag pattern visually distorts the driver's peripheral vision, making the driving lane look artificially narrower than it actually is. This tricks the driver's brain into feeling a sudden sense of confinement, instinctively forcing them to lift their foot off the accelerator and slow down before they even register that a pedestrian crosswalk is ahead. The bleed hole in airplane windows. Number 5 is a tiny detail that keeps you alive every time you fly. If you look closely at the bottom of a commercial airplane window, you will notice a tiny solitary pinhole. This is officially known as a bleed hole. During the early era of commercial jet travel in the 1950s, aircraft engineering teams began designing planes to fly at much higher, highly pressurized altitudes of 35,000. They realized the extreme pressure variance between the cabin and the sky could violently shatter a solid window pane. To solve this, they created a 3-pane window system with this microscopic relief hole drilled into the middle pane. It allows air to slowly circulate, balancing the pressure so that the crushing structural load is borne entirely by the ultra-strong outer pane while preventing frost from blocking your view. The alternating teeth of a zipper. At number 4 is a mechanical marvel we use multiple times a day, the humble zipper. It was perfected in 1913 by a Swedish-American electrical engineer named Gideon Sundback. Early closures on boots and clothing involved dozens of tedious tiny hooks and loops that took forever to fasten. Sunback wanted to engineer a fluid, single-motion mechanism to replace them. Under a microscope, his zipper relies on interlocking geometry. Each individual tooth features a tiny protruding hook on the top and a perfectly molded hollow pocket on the bottom. His slider mechanism is engineered at a precise 45-degree angle, temporarily bending the track so the hooks fall perfectly into the opposite pockets, locking with enough friction to hold heavy military and winter gear together. The ceramic saucers on power lines. Coming in at number 3 are the strange, heavy ceramic or glass geometric saucers attached to high-voltage power lines, known as pin insulators. High-voltage electricity is incredibly volatile. It constantly looks for the absolute path of least resistance to escape into the ground. If the raw wires touch the wooden utility pole directly, the electric current would surge straight down, instantly causing a fire or electrocuting anyone nearby. Power grid engineers designed these smooth, umbrella-like saucer shapes to create an impossible barrier for the current. Even during a massive rainstorm, the underside of the overlapping saucers stays completely dry, breaking the conductive pathway of water and keeping the electricity trapped safely inside the copper lines. The color blocks on food packaging. Our runner-up at number 2 is hidden on the packaging of almost every item in your grocery store. If you look under the folded plastic flaps of a chip bag or the bottom cardboard tabs of a cereal box, you'll find a row of mysterious colored circles or squares. Industrial printing engineers implemented these printers' color blocks to manage high-speed automated packaging. Industrial presses print packages by layering individual colors like cyan, magenta, yellow, and black at lightning-fast speeds. As thousands of boxes fly down the conveyor belts, automated electronic eyes scan these exact blocks. If a single color circle is misaligned by even a fraction of a millimeter, the machine immediately flags that the press is running off center, automatically discarding the package before it can ever hit a supermarket shelf. The concrete coastline tetrapods. And finally, coming in at number 1 are the colossal alien-looking concrete structures that line coastlines and harbor walls around the world, known as tetrapods. Weighing up to 40 tons each, these massive 4-legged blocks were invented in France in 1950 by engineers Pierre Danel and Paul Angles d'Aurillac. They noticed that traditional flat seawalls were constantly cracking and collapsing under the direct, raw, kinetic force of ocean waves. They designed this unique 4-legged shape so the blocks would interlock loosely like puzzle pieces. Instead of fighting the ocean wave with a solid barrier, tetrapods allow the water to flow through and around the gaps. This completely scatters and neutralizes the wave's destructive energy, protecting entire coastal cities from being slowly washed out to sea. Thanks for watching. If you learned something new today, subscribe for a new Top 10 every single week. Click right here to keep watching, and we'll see you in the next one.